Today we're going to talk about the circumcenter. The circumcenter is the point of intersection of the perpendicular bisectors of the sides of the triangle. And what does that mean? Well, when we're talking about bisectors, we're talking about the midpoints. And when we're talking about perpendicular, we're talking about the line that is perpendicular to the sides. And so we can draw this on a triangle like this, A, B, and C. We can find the midpoints. How do you find midpoint? Well, the midpoint is, the formula is x1 plus x2 over 2 and y1 plus y2 over 2. And so if I take these points, for example, I can show that negative 4 plus 2 over 2, and this one is 1 plus 5 over 2, will give me what I got here. Negative 4 plus 2 divided by 2 gives me negative 1. And 1 plus 5 is 6, divided by 2 is 3. And there is one of the midpoints. And I do this all around for each one of these. And these are the midpoints that I got by doing that and by using this equation. Now what I'm trying to do, I'm going to just draw a perpendicular as well as I can, but I can't just rely on that because by eyesight I can't really know that it's 9 degrees. But just to give you an idea of what we're looking for, I'm just going to make a perpendicular line to this approximately and make another perpendicular line here going through the midpoint. And then make another perpendicular line here going through the midpoint. And as you can see, they all meet approximately here. And this point here is the same distance as this vertices to this point, this vertices to this point, and this one to that point. The circumcenter is also the center of a circle, circumcenter. And so if I were to draw a circle, it would go something like this all around, and I would find that the vertices, these points, are all on the circle. This would be the center, and the distance between each one actually represents the radius. That would be the distance. So let's find out, what is this point? Now, you can't just do it like this by looking at it. You have to do it algebraically. So one of the things we need, because it's perpendicular, we need to find the equation of this line by using this slope here and then finding the negative reciprocal to then apply it to find this line. By using the negative reciprocal of this line, the slope of this line, and using the midpoint, we can find the b value. Now I've done it for you here, and you can see that I've used each one of the points, and there they are. And I've used the slope formula, y2 minus y1 over x2 minus x1, and I've used these points here, okay? And then I have plugged them in to each one. And I got 2/3 for the slope here. Perpendicular is negative reciprocal, so the opposite sign, and then you flip the numerator and the denominator. I did it for this one and this one, for all three of them. The equation of the right bisectors, how do we find that? We use the perpendicular slope and midpoint to solve for b. And so that's what I'm going to do for you here. And so if we look at this one here, here we go. I have here the first one, the perpendicular slope and a point. And so I'm going to plug everything into this. So here we go. I'm going to plug the y value. This is a y and an x. And so I'm going to put in the 3. The slope is negative 3 over 2. The x is negative 1. And then find for b. 3 is equal to 3 over 2 plus b. Bring that over to the other side. 3 minus 3 over 2 is equal to b. Let's change this so that we can have the same denominator, and that would be 6 over 2 minus 3 over 2 is equal to b, and so b is equal to 3 over 2. Now using this b value and using the m value, I can create my equation. And so let's do that. And we've gotten y is equal to negative 3 over 2x plus 3 over 2. Now you can do that for every one of these. So the next one you would do would be number 2. And number 2, we would use the point, the perpendicular slope, which was, if we can just remember here, remember we did them all here. Here they are. So the next one for BC is 1/2 because we're using the perpendicular slope. So let's bring that here. And we've got M perpendicular is 1/2. And the point of the midpoint of that one, that was the BC, which was 1/2. And so BC, the midpoint of BC was 4 and 1. And we can do this again, y equals mx plus b, and plug in the 1, the slope, the x value, and I'm just going to move this way here. We've got 1 is equal to 2 plus b. Bring that over. B is equal to negative 1. And so this equation now that I've created, it's y is equal to 1/2 x minus 1. And then I did it with the third one also, but I'll just give it to you. It's the same thing. You take the perpendicular slope, which the last one was 5 over 2, which you can see it right there. And the point that we used was 1, negative 1. And if I do that, what I get is this equation, 5 over 2x minus 7 over 2. And so these are my 3 equations of the perpendicular bisectors. Now what we want is to find the point of intersection. How do you find the point of intersection? Well, do we need to use all 3 equations? No, we don't. So let's use 2 of them. So how about we use this one here and this one here. And then what we're going to do is once we get this point of intersection from these 2, we're going to plug it into the third one to check and see if it worked out for us. So here we go. Let's do that. So I'm going to keep this so that we can see them clearly. And I am going to write these out. And you know how to find a point of intersection by using substitution or elimination. I'm going to use substitution, y equals y. And so as you can see, I'm going to put negative 3 over 2x plus 3 over 2 is equal to 1/2 x minus 1. And keep these together, so bring that over and bring that one over there. Negative 3 over 2x minus 1/2 x is equal to negative 3 over 2 minus 1. We're going to put 2 over 2 so that we don't, so that we can right away use this common denominator. This is going to give me negative 4 over 2x is equal to negative 5 over 2. Negative 4 over 2 is negative 2. X equals negative 5 over 2. And then when you divide, we're dividing both by negative 2. Whenever you divide by a fraction, you're actually multiplying by its reciprocal. And so x is equal to 5 over 4. Okay. Now once I have this, all I have to do is plug this into either this equation or this one to find the y value. So we can plug it into this one. So y is equal to 1/2 x minus 1. Plug the x into here. y is equal to 1/2 times 5 over 4 minus 1. I'm don't have much room. Let me continue over here. And so y is equal to 5 over 8 minus, let's do the common denominator. And so that'll be 8 over 8. Y is equal to negative 3 over 8. Now, as I said previously, we only need 2 equations to find the point of intersection. However, because we have 3 perpendicular bisectors, we want to make sure that all of them are going through that point. So now I'm going to take these two, this point, so that's our POI that we have, 5 over 4, negative 3 over 8. And I am now going to take this, put it in red so we can see it here. Okay. And we're going to put it into this equation here. So our POI, 5 over 4, negative 3 over 8. This is our POI. So let's see if it works here. And so what we have to do is just plug in the x value into here. And if the y value is negative 3 over 8, we know we've done it right. So let's just erase this here. And so I've got y, hopefully, will work out to this. We've got 5 over 2 times 5 over 4 minus 7 over 2. And let's continue on here. Y is equal to 25 over 8 minus, this we want as an 8, so we're going to multiply by 4, so that's minus 28 over 8. So y is equal to negative 3 over 8. That's exactly what we wanted. So we know that our POI, our point of intersection, is correct because it satisfies these 3 equations. We solved it using 2. We checked it using the third one. And let's look at our diagram to see how close we were. If you look at this diagram, this looks like 5 over 4 is about 1.2. So maybe we're off a little. Again, this is just a diagram. And then negative 3 over 8, you can see that it's a very, very small space from the x-axis. And so it is negative 3 over 8 is a small number. And so we're going to say, we're going to congratulate ourselves and say 5 over 4 and negative 3 over 8 is the POI. It is also the center of the circle. And now if I wanted to know the radius of the circle, I can take any one of these vertices and find the distance between these 2 points, and that will give me the radius of the circle. Okay? And that's how you do this. And if you were going to do that, the distance equation is a square root of y1 minus y2 all squared plus x1 minus x2 all squared. And that's how you can find the distance between any one of these vertices and this point. To prove it, you can do it for all 3. And if all 3 have the same distance, that's another way of knowing that this is the center. Of course, the first thing we had to do was to find the center. But if you were asked to prove it in another way, you could take the distance formula and use these vertices here, this one and this one, and this one and this one, and this one and this one, and see if they all add up to the same thing. Okay? So that was for circumcenter. Now the next thing we want to do, because in a triangle there are different points of intersections that are important. The next one we're going to do is the centroid.